So we have our notes. Sure, I'll carry that for you. We're finishing up our notes on page 21. We're not finished, we're starting. 227 notes. So here we go. Look at this first equation. You have seen these before. This is not anything new. What would you do if you found this equation and you had to solve it? What would you do? Multiply the whole thing by 4. Now, groupies, there are other options, but I'm telling you right now, the easiest thing to do is to multiply everything by 4. That is the easiest thing. Most of you do not like fractions, and this is going to get rid of the fractions. Can you see that? This is going to cancel this. This is going to cancel this. And this is going to cancel this. So what's left? X minus 1 plus x plus 4 equals 3. Isn't that easy? Now you have a regular old equation to solve. So let's see. We've got a couple of x's here. What do we have here? A negative 1 plus 3. Now, what do I do now? Subtract the 3 over. I am not going to panic. Don't I get 0? Yeah. So I'll divide both sides by 2. No big deal. X equals 0. And we're done. Done. That is easy. Now, I don't want you making this one any harder. This one is also easy. Now, there's a fraction in it, right? Let's do what we did here, and let's just get rid of the fraction. What would I have to do to get rid of the fraction? Multiply by x. And when I multiply by x, I have to be very careful to multiply everything by x. And the reason I did it is so these would cancel. So now I have x squared plus 2x equal to 15.
Can we take an x out?
No. Exactly. This is a quadratic equation. This is an x squared. And you always have to have your x squareds set equal to 0. So Chandra said move it over, and he's right. Move the 15 over. Now what do? Now you have choices. You could factor, and I think that's an easy one to factor, right? I could factor that. What else could I do if I didn't want to factor? I could use the quadratic formula. If you want to, you can always use the quadratic formula, but that one does factor. So I'm going to get 2 answers this time. X equals negative 5, or x equals 3. Now those equations kind of looked scary when I started, but they turned out to be very easy. What about the next one?
Get rid of x.
Get rid of x. So again, you do not like having a denominator, so we're going to get rid of the denominator. So we will multiply every single thing by x. That will leave me with x squared. Now gang, when you multiply this by x, the x's are gone. So all you have left here in the middle is 12. Not 12x, it's 12, because the x's cancel, equal to 7x. Now, who was paying attention a minute ago? This is the same kind of equation. Bring it over. And notice when I brought it over where I put it, so that my equation is like in the normal order. What do?
Factor it.
If it factors, I factor it. Max is factor?
Yeah. So
How?
it's x minus 4, x plus 3.
Yep.
And then you
flip it over, and then x will equal 4x.
Yep. He's right. What do you think? Are you okay with that? Everybody thinking, I got this. And then we look at the next one. I think you still have it though. I think you got this. So 2 minus 3 over x plus 4 equals 12 over. Now I'm going to pull a fast one on you. I'm going to write x plus 4. In other words, what am I doing there in that denominator? I'm factoring it, right? I'm factoring that denominator. What's this denominator? 1. So I have another problem that's just full of fractions, right? And if I wanted to get rid of every fraction, I want to get rid of it all, what would I have to multiply by to make that happen? Would multiplying by x plus 4 be enough?
No.
Why not? Because you still have an x. So I guess I'm going to have to multiply by an x and an x plus 4. Nothing cancels here. So that is going to be, I'm going to distribute. So that is going to be 2x squared plus 8x. 2x times x, 2x times 4. Minus, okay, now this part cancels. So minus 3x.
Equals 12.
And over here, everything cancels, so I'm left with 12.
Can we combine the x's?
We can. So we have 2x squared plus 5x.
Minus 12.
Get it set equal to 0. Now, it factors, but some of you don't like to factor when there's a number out here in front. But it does factor. The 2x and x. That's how you get 2x squared. Now I need things that are going to give me 12.
3 and 4.
3 and 4 seems to be a good option. Minus 3 plus 4. Oh my gosh, Mrs. Ford, how'd you do that? I'm foiling in my head, I'm foiling. The little wheels up here are going round and round. This makes 8, and this makes minus 3. What is 8 minus 3? 5. If you have numbers in the different order, it doesn't give you 5. You gotta have it giving you 5 when you FOIL it. So what's the answer? 3 over 2 or?
-4.
Beep, 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 beep. These are my extraneous root radar. Why are they going up? Look at the original problem. Can I put a -4 back in for the x here? What would happen if I did? I get a 0 in the bottom, right? Is that allowed? No. This is an extraneous root. The only answer is 3/2.
Wait, what?
Oh my gosh, Mrs. Ford, do I have to be on the lookout for that? Yes, you do. The denominator can never equal 0. So whatever answers you get, you want to make sure it doesn't give you a 0 in the denominator when you plug it back in. Notice over here, I didn't worry about it because my denominator was x. Is it okay if I have a 4 in the denominator? Is it okay if I have a 3 in the denominator? Yeah, it wasn't a problem. But over here, -4 would make that 0. So, can't be. The only answer is 3/2.
So if it makes it a denominator.
If it makes the denominator 0, you throw it out. You know about those extraneous roots. All right, let's see if we get another one done here. So you're looking at this monster and you're thinking, whoa, things got hard really fast here. Let's see. What do you think I'm going to do with this last denominator? I'm going to factor it out, right?
Oh, that works so nice.
And how does it factor out? X plus 4, x minus 1. Somebody said, boy, that works out so nice. It almost always does, so be on the lookout for that.
So can we multiply by both?
Multiply by both, Ferris says, and I think he's on to something.
Yeah,
We're going to multiply by x minus 1 and x plus 4. We're going to multiply by x minus 1 and x plus 4. X minus 1, x plus 4. We are multiplying everything by both of these because you have to multiply and cancel everything. So it wouldn't be enough to just multiply by one of them. You need to multiply by both of them in order to get rid of everything, all the denominators. Okay, so what happens here? The x plus 4s are gone. What do I have? 4x squared minus 4x. Kids, don't forget your distributive, right? Plus, right, now what happens here? 3x plus 12 equals 15.
Don't the x's cancel on this? Just a
Zion,
negative x.
Chase, and Jalen. All right, here we go. What would you suggest we do now? The denominators are all gone, so things look a little better. We can add these together, right?
Negative x.
So 4x squared minus x. And then somebody said subtract the 15 to get 0. Now your choices are factor it. I think it does factor. But if you don't want to mess with factoring it, you can always use the quadratic formula. I think if this is right, I foiled it, I think, correctly. So what are my answers? Set them equal to 0. So this one's x equals 1. This one is x equals negative 3 over 4. I can do that in my head because I'm old. If you can't, it's fine. You write it over to the side. Subtract the 3, divide.
I got 4 squares.
No, when I FOIL, I get negative 4, positive 3. That's how I get the negative 1. Uh-oh, Mason says we got trouble in River City right here. Because what happens if we put 1 in? You get 0 in the bottom, and that's not allowed. So the only answer to the problem is negative 3/4. Okay? Now, I'm going to do something I don't do very often. I'm going to stop and let you go after we wish luck, best of luck, to everyone who's participating.